Welcome back to The Explainer. I'm absolutely thrilled you're here today because we are looking at a massive paradigm shift in software architecture. If you've been following the rapid evolution of AI coding agents, you know we've hit a serious bottleneck. Basically, our human-centric tools, they're completely paralyzing machine-speed AI. Today, we're unpacking a massive breakthrough designed specifically to shatter that bottleneck. It's called AXIOM, an agent-native autonomous software engine. We're going to see exactly what AXIOM is built for, and more importantly, how its underlying systems actually work.
Think about your own workflow for a second. How long do you typically wait for your code to compile or, for your integration tests to run? 5 minutes? 15 minutes? As humans, we have this biological tolerance for waiting, right? It allows us to go grab a coffee while the CI pipeline just does its thing. But an AI agent, it needs millisecond feedback to maintain its autonomous reasoning loop. Literally, if an AI agent has to download a 500 megabyte repository, edit raw text, and then wait 5 whole minutes just to find out it hallucinated a variable name, its autonomy just completely collapses. It just breaks.
Okay, let's dive right into the roadmap for this explainer. We're going to cover 1. The legacy code problem. 2. Enter AXIOM, agent native software. 3. Abstract syntax trees explained. 4. Sub-millisecond micro-VM sandboxes. 5. AI swarms and zero trust. And 6. The future of code.
Let's kick things off with Section 1, the legacy code problem. Built for humans, breaking for AI. Let's look at the fundamental friction here.
So when we look at these contrasting paradigms, traditional Git and CI pipelines rely on storing raw text lines, mainly because, well, humans read text. It forces these long 2 to 15-minute asynchronous loops, and then we have to manually resolve text merge conflicts when we inevitably step on each other's toes. AXIOM basically tosses this out the window. AI agents don't think in lines of text. They reason about functions and logic. So instead, AXIOM represents code as abstract syntax tree graphs. It delivers sub-15 millisecond synchronous feedback, and it completely replaces those manual merge conflicts with automated swarm CRDs. Honestly, downloading local file clones and waiting for text warehouses to sync, that is officially a thing of the past for AI.
Which brings us right to Section 2. Enter AXIOM, agent native software.
What's really fascinating here is that AXIOM isn't just some Git clone. It actually turns the repository into an active machine-addressable execution engine. Let's fire through the core features. First off, no local file clones. The repository just acts as an always-on model context protocol server, so the agent simply asks for function definitions using a basic JSON RPC query. Every single hypothesis the agent makes is validated in sub-millisecond sandboxes. Plus, AXIOM uses this smart blast radius pruning to run only the exact tests affected by a change. It also uses tree CRDT swarms, meaning you can have 50-plus agents working simultaneously without stepping on each other's toes. And finally, zero-trust cryptographic seals ensure absolutely nothing gets merged without mathematical proof of success.
Moving right along to Section 3. Abstract syntax trees explained. Let's pull back the curtain on this.
Okay, so the absolutely crucial point to understand here is that agents think in structural graphs, not text. What AXIOM does is parse every function into normalized syntax nodes, completely stripping away all the messy whitespace and formatting. Then, it creates a Blake3 hash, which is essentially a unique digital fingerprint of that exact node, and stores it in a global content addressable storage. Now you might be wondering, why does this actually matter? Well, if multiple agents generate the exact same boilerplate utility function, AXIOM recognizes that identical fingerprint and just reuses the precompiled bytecode instantly. We are literally talking about 0 millisecond compilation latency for known functions. It's a total game changer.
Just think about that number for a second. 99.9%. It is a jaw-dropping stat. See, when an agent changes a function, AXIOM doesn't just blindly run the entire test suite like we're used to. Instead, it maintains a bidirectional reverse call graph to mathematically calculate the exact blast radius of the change. To put that into perspective, if you have a 5,000 test repository and the agent tweaks just one node, AXIOM might only run the 1 to 3 tests that actually touch that specific function. It is pruning away 99.9% of redundant test execution time, and that is exactly how it keeps the AI's feedback loop so incredibly fast.
But the real world is messy, and sometimes agents still need to search for raw strings, right? Things like SQL statements or configuration keys. To handle this, AXIOM actually maintains a zooked trigram search index right alongside the AST graph. Basically, it's an ultra-fast, in-memory sliding index. The result of this is that non-structural string and regex queries execute in under 1 millisecond, and it does all of this without ever even touching the host disk.
This leads us nicely into Section 4, sub-millisecond micro-VM sandboxes.
Now, this next concept, this is the real aha moment of the entire architecture. We all know standard container startup takes hundreds of milliseconds, right? Mostly because it has to copy memory. AXIOM bypasses this completely by using pre-warmed KVM snapshots and a Linux kernel feature called user-fault-fd lazy paging. The best way to think of this is like streaming a movie on Netflix instead of downloading the whole massive file before you can hit play. When a test needs to run, the micro VM boots in under 1.2 milliseconds with absolutely zero initial RAM copying. It just resumes instantly using its saved CPU registers. Then, when the guest accesses a memory page it doesn't have yet, the host kernel traps the fault and resolves the missing page on demand from a read-only backing file in roughly 10 microseconds. It is just such an incredibly elegant way to cheat the system's startup latency.
So let's break down how this actually creates a complete round-trip feedback loop in under 13 milliseconds. Step 1. The snapshot resumes almost instantly. We're talking 1.2 milliseconds. Next, the agent's code diff is mapped directly into guest memory in just 0.8 milliseconds. Then, the host and guest communicate over a virtual memory socket, completely bypassing the clunky TCP/IP stack in an insanely fast 0.3 milliseconds. The actual fastpath execution of the test takes about 6 to 9 milliseconds. And finally, emitting the structured JSON report back takes a mere 0.7 milliseconds. You add all that up and the AI agent gets deterministic verification of its code in less than 13 milliseconds. No way, right? It's that fast.
Which brings us to Section 5, AI swarms and zero trust.
Imagine if 50 agents were editing a repository at the same time. Standard Git merge conflicts would completely paralyze the system, for sure. AXIOM solves this using tree CRDTs. You can kind of think of it like Google Docs, but for code. Code changes aren't treated as simple lines of text anymore. They're treated as commutative tree operations. So inserting, updating, or deleting a node, it's all mapped out mathematically. Because they use these really clever deterministic tie-breaking rules, 50-plus agents can edit decoupled functions in parallel without generating a single textual merge conflict. The whole shebang just resolves perfectly into the exact same AST Merkle root.
Now, there is a very specific core philosophy driving this entire architecture, and it's this. No code is committed without mathematical proof that it passed verified sandbox test inside a sealed execution jail. Let's think about that. When you have non-deterministic large language models out there generating massive volumes of code entirely autonomously, your whole threat model just flips. You literally cannot rely on human code review alone anymore. You need absolute rock-solid zero-trust security. And here's exactly how AXIOM enforces that zero-trust policy. Every single commit produces a hermetic SLASA Level 4+ cryptographic attestation. That is the absolute gold standard for supply chain security. It basically acts as this unbreakable chain of evidence. It mathematically links the parent Merkle root to the newly mutated commit root. It attaches the agent's cryptographic identity. It hashes the exact prompt that was used, attaches the sealed micro VM trace just to prove the tests actually passed, and then it wraps the entire thing up in a signature. So before any code ever hits production, you have an absolute receipt proving exactly how, why, and where that code was generated.
Finally, we arrive at Section 6. The future of code.
So, what does this all mean? I want to leave you with a question to think about. When repositories shift from being passive text warehouses waiting around for manual CI pipelines into these active, machine-addressable execution engines giving sub-15 millisecond feedback, is the era of human-centric coding over? AXIOM really gives us a fascinating glimpse into a world where software development operates at true machine speed, fully unlocking the potential of autonomous AI coding agents. Thanks so much for joining me for this explainer. I really hope this helped you map out this incredible paradigm shift. Keep learning, stay curious, and I'll catch you in the next one.